So to begin with today, first thing I want to talk about is, you go ahead and say that assignment aside. Look at your packet, your note packet from yesterday. The second page where we had the sine and cosine functions and talking about writing equations for those. Okay? That's up to you, yeah? All right? So what we're going to do is we're going to use the general form that we talked about yesterday. Y equals A sine B theta. Okay? And remembering that A is the absolute value of A is the amplitude. So we take the absolute value of that, we get the amplitude. And B is the number of cycles from 0 to 2 pi. Okay. Remembering that, then using the information they give us, I want to write some equations here. Okay? So for instance, on number 1, if the amplitude is 4, then A becomes 4. And we're going to put everything in sine. We're not going to use cosine right now, but 4 sine. Well, this doesn't give us B, it gives us P. So a quick recall, to find P, or excuse me, to find B. Find B, how do you find B given P? Yeah.
2 pi over P.
Good. The formula is 2 pi over P equals B. So in this case, 2 pi divided by 2 pi would be 1. So B would equal 1. So that would be y equals 4 sine 1 theta, which if you don't need to necessarily put the 1 there. We wouldn't usually write that, so we'll erase it. It'll just be 4 sine theta. That would be our equation. Okay? If we're writing a cosine equation, we just write 4 cosine theta. Y equals 4 cosine theta. Now, is there another equation that would satisfy that? Using sine or cosine? Yeah, why would negative 4 work? Good. Yeah, the amplitude is the absolute value of A. So you could also put negative 4 in, and that would work. Now, today I'm just going to write my equations using the positive value, but the negative value would also work there. Okay? All right, so go ahead and go answer those 6. Zoom that in just a bit. Okay. So y equals 1.5 sine 2 pi divided by 1/2 pi would be 4. Okay, so we get B equals 2/3 there, 2/3 theta. Any questions on those? Yeah, maybe. Sure. Yeah. Okay. Well, we're going to go ahead and move on from there. I want you guys to slide down the page there to these here. we're going to sketch the graph of each sine curve from the interval of 0 to 2 pi. Now, yesterday we did this on a graphing calculator. Today, I'm going to do it by hand. I'm going to put in my axis right here. Now, this is the theta axis. This is the y-axis. Okay? Now, please remember what sine means. Okay, so let's go back to our unit circle and review that real quick. I referenced it yesterday when I showed you the video at the end of class. Okay, I was trying to get you kind of used to what we're going to talk about a bit today. So when you are graphing y equals 2 sine theta, notice you are graphing an ordered pair of theta, y. It usually be x, y, but our variable's theta, so it's theta, y. And theta, when you're dealing with a unit circle, okay, we're thinking about these values. Theta is your angle measure from standard position to terminal position. So we start here, and we're moving upward. And we're going to be measuring theta in radians. So for instance, that would be pi over 6 radians. So one coordinate that we would have when theta is pi over 6, well, sine, if you recall, if we drop the altitude here, this little line that I drew is just making the noise there. Okay. I don't know why. Probably because I'm type A. Okay. Drop the altitude there. And I'm looking at, in terms of 1, I'm looking at opposite side and adjacent side. Well, sine is opposite over hypotenuse. And the opposite side length happened to be 1/2. Right? It was the y coordinate right there. So this ordered pair at pi over 6 would be pi over 6, 1/2. That would be the y value there. Okay. So the one way to think about it is this is always theta, but this one, remember in the unit circle, our opposite side we always called sine. So the sine of theta is 1/2 here. Okay, now that's different than when we graph cosine. Okay, this is graphing sine. When I graph the cosine curve, I am still graphing theta, but it's not theta sine, it's theta cosine. And so I'm using the same angle, however, my value for cosine is what? Yeah, it's the x value. It's the √3/2. So when you graph the cosine curve, you're actually graphing this angle in relation to the adjacent side. When you're graphing the sine curve, you're actually graphing the angle theta in relation to the opposite side. Okay? So note that there will be times when these points are the same. Right? So if I go to my 45-degree angle here, or pi over 4, my coordinate now is pi over 4, comma, √2/2 for sine. But for cosine, it's also pi over 4 and √2/2. They're exactly the same. In fact, if we graph the sine and cosine curve at pi over 4, they intersect. They have the exact same point. Right? When we go to pi over 3, okay, so when we're dealing with this one right here, our sine curve is pi over 3 √3/2, and our cosine curve is pi over 3 1/2. So the cosine and the sine. Okay, how many are following along on that? Okay, just one last piece here. This right here, when I do sine and cosine on this one, everyone go ahead and write those values down. The coordinates for sine at pi over 2 and the coordinates of cosine at pi over 2. Okay, so sine is 1, cosine is 0. Whereas right here, they're switched around, right? So when we're dealing with sine at 0 degrees, sine is also 0. When I'm dealing with cosine at 0 degrees, sine is, or cosine is 1. Okay, so 0, 0 and 0, 1 here. Here it's pi over 2, 1 and pi over 2, 0. Okay, you guys with me? All right, so how many remember the graphs I showed yesterday? Okay, I'm going to try to switch to those here. Last time I messed up my recording completely. Let's see if I can make it work this time. All right, here's my sine curve again. Okay, the sine curve. Right? Starts at 0. Starts at 0. Goes to pi over 2. That's when sine is 1. Right? So if you're referencing back to your unit circle, the points we just came up with. Okay? And then it starts going around the unit. So we only did this quadrant. But all these coordinates you just came up with, those are the ones that are plotted right here. Now we're going to only focus on specific ones when we graph it. We're going to focus on this one, which we call a 0 because it crosses at 0. We're going to focus on this one, which we call a maximum. We're going to focus on this one, which is a 0. We're going to focus on this one down here, which we're going to call a minimum. And then we're going to focus on this one back over here, which is a 0. Okay? That is the sine curve. Now notice it starts at 0, 0. Okay? Now, if I graph the cosine curve, notice where it started. Started at 0, 1, right? Now remember what we just had on our unit circle. It says cosine at the beginning is 0, 1. Okay? And then our values start decreasing in value. Okay? So if you think, and we'll come back to that here in a minute. Let's see. Okay? If you think back to when I told you guys how to complete the unit circle, remember I say, hey, list this as root 4 over 2. And then from here, you're counting down root 3, root 2, root 1, root 0, right? Your cosine values or your x values are decreasing in value. That's why when we go back to, let's see if I can get back there again. When we go back to this, notice as this is going, our x values our values for y are decreasing in value. Okay? So when we started the graph up here, it started at 1, 0. That would be the root 0 over 2. And then we keep decreasing in value, or excuse me, that would be the root 4 over 2. And then we keep decreasing in value until we get to the 90-degree mark, which is now root 0 over 2. So the y value is nothing. And then it starts increasing in value again. This length right here of the triangle, the cosine length, starts getting longer. That's why these values get further away from 0. And then this cosine length starts shrinking. That's why the values get closer to 0 again. And then the cosine length gets longer again. That's why they move away from 0 again. Okay? Converse that to the sine, okay, which is, notice you're graphing this length, your opposite length now. So as we started this one, that length starts out really small and then gets really long, and then it starts shrinking again until it gets to 0. That's why we're at 0. And then it starts getting longer, so we move away from 0. And then it eventually starts shrinking again. That's why we're moving back towards 0. Okay. Can everyone visualize what we're graphing now? Okay. That is a very abstract thing. Like a lot of times you'll say, hey, graph it. Most students can graph it after. I could have shown you how to graph it without explaining what you were graphing. A lot of students will have no idea what they're graphing. What are you graphing? Well, I'm graphing sine. Well, what is that? It's like a curve. You know, like see, sine. Okay, like what are you actually graphing? I am graphing the length of the opposite side in relation to the radian measure of its angle moving around the unit circle. That's what you are graphing. Okay? All right, so I'm going to kind of expand on that a bit as we go, but all right. Let's move back to this page here. Now let's actually graph this. You'll notice that everything we've done has been 1 sine theta. That 1 represents your amplitude. Well, this graph right here says 2 sine theta. That means I am taking whatever sine theta is. So remember all these values of sine theta here? So, for instance, this one, sine theta is 1/2 at pi over 6. Okay? So when we get to pi over 6, it's going to be 1/2. Well, that's with 1 sine theta. That would be this would be if you're at 1 sine theta. Now, these values work for the sine of theta. Notice the difference between that equation and this one. This one says 2 sine theta. Okay, so I'm going to show you how to graph it, then I'm going to explain what the 2 did to you. Some of you are going to see that, but then we're going to actually apply it to the unit circle. Okay, so the way we graph this, we're going to use this little phrase right here. 0. And then max. Well, it's nice to know our amplitude. Our amplitude here is 2. And our A term is 2. That means our max is going to be 2. So 0, max. So if I'm going up by 2 here, I'll write the 2 in this time. 0 max. So the next line will be a 0 again. And then our minimum. Well, if our maximum's 2, and we haven't shifted our graph up or down, which we will eventually do, then our minimum also will be 2. It's actually -2, right? It's down here. 0 max, 0 min, and then 0. Well, what have you graphed there? You graphed 1 complete cycle. Now, a cycle is B. From 0 to 2 pi is what we need to graph. Well, B stands for the number of cycles from 0 to 2 pi. So to figure out how many cycles you need to graph, you need to look at your B term. How many cycles do I need to graph? B is 1. It's just 1 cycle. The length of that cycle we call P. So it's always good to list P. P is 2 pi over B, which in this case is 2 pi over 1. So that's just 2 pi. That means from here to here is a length of 2 pi. So, how many curves do you see? Well, we only have 1, right? There's only 1 there. Now, if I go back to my sine curve, right here, that right there is, oops, I'm sorry. You guys can't see it. That right there is 1 curve. So that 2 sine theta that we have, that 2 sine theta on this graph that we have, did it affect how many times we saw the curve? No. What did it affect? It affected the amplitude. Okay? Let me point this out. When I actually go through and I cut this back here, this is 2 pi. That means half of that length will be pi. And if I want to know my interval, this will be half of pi, which is pi over 2. Okay? Well, notice that pi over 2, we're way up here. You're at a value of 2. Okay? So you're at a value of 2 at pi over 2. If I go to my unit circle, and I go to where pi over 2 is, right here, in y equals sine theta, the value is not 2, it's 1, right? So what I've done is I've taken that, whatever sine theta is, and I've multiplied it by 2. That's all you're doing there. In relation to the unit circle, what does that mean? It means your radius is now 2. Okay? Your radius is no longer 1, it's 2. It's no longer a unit circle. It's technically a 2-unit circle. Okay? That does not change this ratio, though, that you get right here. It does not change these values. It just finds these values and then doubles their length at the end. You find the ratio, the opposite over hypotenuse, and then you double it. That's what you're doing there with amplitude. Okay, what I expect when you graph these is that you always label the lines on the theta axis that contain zeros. So you must label this line, that's 0. You must label this line, that's pi. And you must label this line, that's 2 pi. You do not have to go past 2 pi unless it specifically says to do that. It could say that by sketch 5 intervals or 5 cycles of this graph. That would be, maybe you'd have to go past 2 pi. Okay. Otherwise, you just stop at 2 pi. You did not have to label pi over 2. You could if you wanted. You could always do that to check yourself. Well, if that's pi over 2, that's 2 pi over 2, which is pi. 3 pi over 2, and that's 4 pi over 2, which is 2 pi. It's a good check. Okay? All right, at this point, everyone rate themselves 1 to 5. It's like that's like a buco lot of information right there. Okay? Let's go ahead and move to this one. Let's try this. Okay? Give you a shot to work through all this on your own, with the exception, I'm going to tell you to always find A, your amplitude, or your amp, I guess we should write there, B, and P. Okay? All right, and then get as far as you can on this graph on your own there. Okay, so this little phrase here isn't going to be 0 max, 0 min, 0 anymore, is it? And on this one, it's actually 0 min, 0 max, and 0. Notice it's minimum. Tell your neighbor why it's a min. You have the negative, right? So you go from 0, A is 2, or your amplitude is 2. So we should really call that amp. Okay, B is 4, meaning we're going to see 4 cycles. P is 2 pi over B, or 2 pi over 4, which is pi over 2. Meaning the length of one of those cycles is going to be pi over 2. So you go 0, min, 0, max, 0. Couple ways to actually label all this. You could actually say, okay, I know that's one cycle right there. That's the length of P. That's pi over 2. You could do that if you wanted. Then you could go 0, min, 0, max, and 0. Sometimes it's nice to put just a little mark there. That's 1 cycle, 2 cycles, and then min, 0, max, and 0. So I start here, I cruise down. Make sure you're not making pointy graphs. This is not a zigzag, they are curves. The more you can do it without stopping or picking up your pencil, I found that is a lot easier to draw the curves that way. You should have arrows on the end because they continue. A pin right there. There we go. This whole length, the other way to label these is to say I know that I'm graphing from 0 to 2 pi. I need to have 4 cycles. Right now I have 1, 2, 3. I need one more cycle. All right. Whoops. Better get that other one in there. There, and there. All right. Here's my 4th cycle. So 4 cycles has a length of 2 pi, which means half of that length, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay? 16 cut in half. 1, 2, 3, 4, 5, 6, 7, 8. Right here. If that's 2 pi, this is pi. And then that 8 cut in half would be half a pi, or pi over 2. And that 4 cut in half would be half a pi over 2, or pi over 4. Notice I've labeled that 0. I didn't label that one. That one, that one. If that's 1 pi over 4 and that's 2 pi over 4, this is 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, or 3 pi over 2, 7 pi over 4, and 8 pi over 2. There we got it. What's your interval? Tell your neighbor. On the theta axis, what are we going up by? Okay, are we going up by pi over 4? Not going up by pi over 4. Yes, this line right here is what your interval is. And that is half a pi over 4, or pi over 8. Okay, questions? I think you get it a little better after that one. Okay, let's try one more graph just with sine, and then we'll move to cosine, just for fun. Okay, so here we've got it. List all your pieces. It's nice they tell you A and P. So sketch the graph, then write the equation. It would be nice to know what B is. How do you find B? Good. B is 2 pi over P. Okay? And 2 pi over pi is 2. That means there are 2 cycles, which also means I could write my equation now. Y equals 1 sine 2 theta. A is 1 and B is 2. All right. Some of you already graphed it. I'll let you guys graph it up. So we go 0, 1, negative 1, or 0, negative 1, 0. And we have to do that 2 times. Two cycles. It's 0. We know that one cycle is pi. Second one, there's 2 pi. That's half. Halfway there is pi over 2. And that would make this 3 pi over 2. Okay? Got it? Not too bad. Okay. We're going to move on to a cosine graph. Okay? And the way we're going to do cosine, I want you to turn to page 261 of your student journal. Page 261. The first one we're going to do, we're going to do 2 of them on here together. We're going to do number 2 and number 6. Okay, they are both cosine graphs. All right. Haley, I don't want to hear that kind of language. I'm just joking. All right. Okay. So there's our axis. It says identify the amplitude and period of the function. So let's do that. A and P. Okay, so the amplitude is amp is 1/3. Period is pi, right? It's 2 pi over b. Okay, b is 2. So 2 pi over 2 is pi. Okay, so since my amplitude's 1/3, I'm going to go up by 1/3 here, meaning that this right here is 1. Make it a little easier on us. And cosine has a different little phrase we follow. The phrase we follow is max, 0, min, 0, and max. Why max? Because remember, your cosine curve starts up here at your amplitude. Okay? And that's our 1/3. We go down to 0. And then we go to our minimum, which would be negative 1/3. Then we go to our 0. And then we go back up to our maximum. Okay? Now, this says, this 2 means I have to do that twice. Okay? So I'm going to put a mark here. Haley, do you have a question? Or Hallie, excuse me. No, this is still the theta axis, and this is still the y-axis. You're asking that because on the unit circle, you're dealing with an x value here? Is that what you're... Yeah, we still leave it, we are graphing. When we're graphing it, we're graphing our graph theta in terms of cosine, the cosine value. Even though cosine value on the unit circle is an x value, we're still graphing it on the y-axis. Okay. Good, so this right here, please make sure you don't make pointy graphs. Curve it a little at the end and put your arrow because it's actually curving downward. That's from 0 to 2 pi, so that means this is 2 pi. Well, that does not intersect at the x-axis here. So you're going to have to work your way back. If it's 2 pi, this is pi. Half of that is pi over 2, and none of those actually gave us the zeros. What's half of pi over 2? Pi over 4, that's 1 0. 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, and then 8 pi over 4. You don't have to list all of those, but you definitely have to have these right here because these are your zeros on the theta axis. Okay. It then says, the last thing it says here is describe the transformation of the graph of g as a transformation of its parent function. Well, this is the graph of g. just so you know the parent function looks like this. Or cos theta. I guess technically that should be x. Let's pretend that's theta. Okay? That's the parent function. The parent function would actually start right here, and it would go through one complete cycle. That's it. And it would end right here. Which means the min is right here, the zero's right there, and there's a 0 right there. Your parent function, it doesn't tell you to graph it, but I'm going to graph it so we can compare it. Your parent function looks like that. It's a pretty cool emblem. Okay? Now, that's your parent function, yes. Howdy. Yeah, it is a vertical and a horizontal shrink. So remember, if it happens inside the function with the x value or the theta value, that's horizontal. So this is a horizontal and time. Remember, everything's backwards in there. So it's a shrink by a factor of the reciprocal of 2, which is 1/2. Everything's backwards. And then outside of the function, you're multiplying by 1/3. So outside it's vertical. So it's a vertical shrink, my bad, by a factor of 1/3. Okay? So let's make sure we're clear on what's happening there. If I were to take this point right here, let's recall inside here, this deals with horizontal. When I'm dealing with horizontal, I am shrinking horizontally, means I'm shrinking towards the y-axis. That means this point, which is currently right here, would shrink half the distance to y. So currently, it's 1, 2, 3, 4, 5, 6, 7, 8. Half that distance is 4. It would move it to here. That's after the shrink. So I'm going to put a 2 there because that had to do with that too. And then vertically, this point would shrink towards the x-axis. So the distance currently is yeah.
So does that make cosine equal to sine theta minus 180?
Hey guys, let's finish this up. If I'm shrinking towards the y-axis or the x-axis vertically, it's going 1/3. The current length is how far? Well, currently it's at... No, what's this length right here? From here to here. 1. Oh, okay, 1. Thank you. And then we are going 1/3 of that, which is right there. Okay. Unbelievable. That's my bad. All right? That point would go to there. Okay, so you're shrinking horizontally half the distance and vertically 1/3 of the distance. Okay? Okay, the ultimate, number 6. Woohoo! Man, I'm pumped. All right. Go ahead and talk about what you're going to do there. Hey, guys, the first thing I want to do is to let's talk about what the shifts are. Okay? So, if you didn't do this already, tell your neighbor what the shifts are in this one.
Well, it's
Okay, let's pause here. This right here That is it happening with x inside the function or outside of the function?
With x.
Or outside of the operation, I guess. So it's inside with x, so it's a horizontal. And since we're adding, it's a translation. And we are moving to the left because it's backwards in there, right? Pi over 2. Horizontal translation, left, pi over 2. And then this negative 3 is on the outside. That means it's vertical. And it's subtracting, so it's a translation. And it's going down 3. That means if I have the parent function, which we know is max 0, min 0, max. If that's our parent function, and we know that this entire length right here is 2 pi, right? That's one cycle of the parent function. So just so we're clear, the parent function f, we call it f of x, is equal to cos x. That's what we just graphed. That's 2 pi, which half of that is pi, and half of that is, conveniently, pi over 2. Now tell your neighbor, why is that so convenient that it's pi over 2? Hey guys, it really makes it easy if your horizontal shift or translation is in terms of what your scale is. Otherwise, it makes it really difficult. Like if I said, hey, we're going to move this pi over 6, it's a little tougher. You want to fix your scale up. Okay? So you want to change your intervals in that case. So this isn't, so it's easy. We can just move all of our points horizontally left pi over 2. So everything just drops back 1. Now you don't actually have to draw the arrows every time. I'm doing it for this graph just because I'm kind of instructing it. And so just so we're clear, there is still negative land over here, right? This is like negative pi over 2 over here. Okay? Now we're not going to usually include those points, but we're going vertically down 3 then. So after we shift that way, we're going, each point's moving down 3. That is my new point. So I'm going to just write a 3 there, just so I know that's my new point. Oops. So notice if I'm going to graph this, I'm connecting all those 3's. Now the problem after I connect all the 3's, oh, I guess I can take this one. 1, 2, 3. There we go. Okay, the problem with connecting all those 3's, do I graph it from 0 to 2 pi now? No, I'm only at 3 pi over 2. Which means if I were to continue out my other graph, max, min, 0, min, max, the next one would be 0. So if I were to take that one, move it over and shift it down, that would be right there. So now I have graphed from actually negative pi over 2 to 2 pi. I'll stop it right there. Okay, that is my graph. Have I labeled the zeros? Well, there aren't any zeros to label there. So how do you label it? Well, you need to at least define your interval, which you've already done. Okay? How many think you got it? Stuff's so cool. Hey, remember this? This, by the way, is the new form. Y equals A cos B times X all plus K. HK again. There it is. Who cares? Yep, who cares? But there it is. All right. We care. That's who cares. All right. Your assignment is to finish that page. I will tell you, when we come in tomorrow, you better not have spent any more than a half hour on it. Because these two right here, these two right here are going to make your brain hurt a little.
Do that first.
Okay? All right.